Hello, so this is a little video about Lenz's law, which is looking at the direction of current in a coil if we bring a magnet near to it. We'll get to the magnet in a minute, but firstly I just want to remind you of the right hand grip rule. So if I place my hand like this, my thumb represents my north pole, the fleshy bit of the bottom of my hand is the south pole, and my fingers point in the direction of the current, okay, so towards my fingernails. So in this case it's coming round. So just like my hand looks like the picture here, you can see the current is going around this way. That must mean that a north pole gets set up at the top of the coil and the south pole at the bottom. Now if I change my current direction, so instead of going from left to right as I look at it this way, it goes from right to left. Okay, so this time it looks like this. Okay, it's coming up and over. The north pole is now at the bottom of my coil and the south pole is at the top. Now obviously if I have a coil of wire that is horizontal, I can just move my hand so that it points like this or like this. And you can see that if current flows up and over the top, I will get a north on the left and a south on the right. Okay. If my current flows in the opposite direction, so it comes from the top over and then underneath the bottom, my north will be on the right and the south will be on the left. Okay, so if I have current going from the left hand side of this screen to the right hand side, hopefully you can see, if you trace it, that to do that I have to go underneath first and then I come up and over. Then I go back down, up and over, underneath, up and over. Okay, and so if I want to position my right hand rule to match this, my current is coming from underneath, it's scooping under and coming up. So this side of my coil is going to be a north and therefore this side's going to be a south. Okay. If I want my current to go in the opposite direction and to come out this way, I know that I'm going to need it to come over the top to come out this side. Okay, so this time it's going to come over, so it comes in, comes over, comes back around the bottom, over, over, like this. So now my north pole would be on this side and my south pole would be on this side. Okay, so that's our right hand grip rule. Now, the thing we need to be aware of for Lenz's law is this. Okay, the coil of the wire that we have here will have a current flowing in it in the direction that will set up a magnetic field, which we know it does, either this way or the other way, north, south, south, north, but it will be set up in the way that tries to stop the magnet from moving, okay, because of Lenz's law. Alright, so we're going to remove the right hand grip rule for a minute and we're going to introduce our bar magnet. I'm going to move this over, and for now I'm just going to concentrate on the left hand side of the coil and I'm going to move the magnet either towards it or pull it away. Okay, and we're going to work out what we need to happen. Okay, if I bring a bar magnet towards my coil of wire so that a north pole is going into it, I need to set up a magnetic field that will stop it from moving. It will try and stop that. I know that if I'm moving inwards, to try and prevent that inwards movement, I need to repel. So I need to set up a north here and a south here. Okay. As soon as I change the direction of my bar magnet and I start to pull it away, the coil still wants to stop the magnet from moving. Okay, and so to go against the movement away, I have to try and attract it back in. So I have to set up a south on this side and a north on the other side. So the current direction is going to flip. Okay. If I turn my bar magnet around, so I have a south pole, if I try and move a south pole in, it will continue to be a south pole on this side of the coil of wire to repel that movement. But if I try and pull my south away, the coil direction of field will have to flip to try and attract it back in. It doesn't want the movement. Okay, so you're always setting up a north and a south on each side of the coil to oppose whatever the motion is. Okay, so now what we have to do is think about what direction that causes the current to flow in. Okay, so I want you to imagine that I am trying to pull the south away. Okay, I'm trying to get that. Let's draw a little arrow here just so that we can remember that. We're pulling the south away. So I want a north pole set up here and I want a south pole set up here. This is where I take my right hand grip rule, and you can use your own hand, and I align it so that I get a north on the side I want and a south on the side I want. Okay, and when I do that, you'll see that what I want is the current to come underneath at the bottom and up and over on the top. Okay, so it comes underneath from the bottom, up and over. Okay, so it's going round and around and around and around, so that at this end the current comes out like this. Okay, that's the only way I am going to get a north pole here and a south pole here. Okay, if I now reverse this so that I'm pushing my south pole in, I need to set up a south here and a north here. Okay, so I'm going to have to flip my hand over. So now I want the current to come up from the top and over. So you can see it's going around this way, hopefully. Okay, so now the current will have to flow in the opposite direction. Okay, so let's check this and see if you've understood. The first thing I want you to do is have a look and decide which pole I need set up on the left hand side of the coil to oppose the movement that I have. Okay, so I'll do the first one for you. I've got a north pole moving in. I want to repel that, so I will get a north pole on this side and therefore, excuse me, a south on this side. So pause the video and have a go at the other four. Okay, so if I've got a north moving away, I need a south to attract it back in. If I've got a south moving in, I need to repel that movement, I'll put a south. If I've got a south, that's the thing that's closest to the pole moving away, I need a north to attract that in. Okay, and now you can use your right hand grip rule to work out which way you need your current to flow. Okay, so if I want my north pole, like in number 1, on the left hand side of the coil, my current is going to need to come from under the bottom and over the top. Okay, under the bottom and over the top. So if I'm going to draw that on, it's coming from the bottom, coming round and then coming back over the top. Okay, and it's going to keep doing that all the way to the end so it can come out this way. Okay, in order to get my current to go over the top. Okay, then for number 2, I need a south pole on the left hand side. Okay, so this time it's going to need to be in the opposite direction. Okay, it's going to come up and over. Okay, hopefully you can give those a go. Okay, so hopefully you've had a go at 2, 3 and 4, and just to clarify, on this side of the loop is the higher point, it's closer towards you, and on the left it's the bottom, but this is the direction that you should have had 2, 3 and 4, so hopefully that has cleared things up a little bit.